Welcome back, science fans. You may have just watched how SpaceX reuses its rockets to speed up their missions into space. If you missed it, click on the link above. But even reusable rockets are an expensive proposition for spaceflight. So instead, imagine a world where going up into space is as easy as stepping into an elevator and pressing a button. Let's dive into the concept of space elevators and explore how they would work and how space travel may change with this technology. Buckle up and get ready for an exciting ride to the stars. Your first question is probably, what is a space elevator? Well, it's just a very advanced elevator, but one that transports payloads from the Earth's surface to space and back again. The machine has a long cable extending from the Earth's surface into space, with a counterweight at the far end to keep it taut. People would travel along the cable, using elevator-like vehicles to reach geostationary orbit or beyond. The concept was first proposed by Russian scientist Konstantin Tsiolkovsky in 1895, and could potentially provide a cheaper and more sustainable way to access space. An essential element is the elevator's cable, which would require anchoring at a point near the equator. Here, the Earth's rotational speed would supply the necessary counterbalance to maintain the cable's upright and stable position. To state this simply, imagine an ice skating duo performing a spin where one person holds the second person as they spin together. As they spin faster, the person being held moves outward due to the centrifugal force. So now, for the space elevator, think of Earth as the spinning ice skater, the cable as the arms connecting them, and the counterweight as the other skater being held. The big question is, how do we build a space elevator? Although it might be a few years away, building one is possible if we continue to advance our understanding of material science. First, we must develop an incredibly strong and lightweight material for the cable, as it must support its own weight and the weight of the vehicles traveling along it. Researchers are currently exploring materials like carbon nanotubes or graphene, which are lightweight and much stronger than steel. However, nothing available is strong enough yet, but there are some promising ideas in development. Check the link in the description for more information. Once we've tackled the cable issue, we can focus on the vehicles, or climbers, as they're sometimes called. These elevator-like vehicles would travel along the cable, powered by solar energy or other renewable sources, to reach their desired altitude. Magnetic levitation, or maglev, is a technology that could be employed to reduce friction and increase efficiency during the climber's ascent. Maglev uses magnets to make objects float above a surface without touching it. It works because magnets attract or repel each other, and we can use this force to make things like trains hover above a track. The object stays floating at a stable height while it moves, and we can use more magnets to push it along. This technology is often used in super-fast trains, and in this case, space elevators. What would it feel like to take a journey up into space on a space elevator? As the climbers ascend, passengers would gradually feel the pull of Earth's gravity diminish, eventually reaching a state of weightlessness as they approach geostationary orbit. Traveling in a pressurized climber, they would be shielded from the extreme temperatures and radiation of the upper atmosphere. In some cases, such as a tourist space elevator, the climber's interior would be climate-controlled to provide a safe and pleasant environment throughout their journey. The ride from the surface to geostationary orbit, located at an altitude of about 22,000 miles, could take anywhere from an hour to several days, depending on the climber's speed. Slow and steady is the name of the game here. Accelerating too fast, and the trip may end up feeling like an amusement park ride. Astronauts can experience around 3G during a rocket launch, sometimes up to 6G for certain maneuvers. However, you and I would tolerate accelerations of up to 2 to 3G for short periods of time. So, let's calculate how long it would take for a smooth ride up to space. If the elevator begins moving and maintains a constant acceleration of 1G, it will take them approximately 90 minutes to reach space. This level of acceleration would be comfortable for most people. At the end of the ascent, passengers could arrive at a space station or a platform in orbit. This location would serve as a hub for various activities, such as scientific research, satellite deployment, and even large-scale construction projects. For instance, parts for interplanetary spacecraft or space-based solar power arrays could be assembled in orbit, taking advantage of the microgravity environment, and significantly reducing the costs of launching these massive structures from Earth. This space station could also provide a staging point for space exploration, as passengers and cargo could transfer to other vehicles designed for deep space missions, or even space tourism. The possibilities are endless, with the space elevator serving as a critical infrastructure component that could enable humanity's expansion into the solar system and beyond. While there are many challenges associated with building a space elevator, including developing the material strong enough for the cable and avoiding space debris, there are significant upsides to solving this technical challenge. If we eliminate expensive and resource-intensive rocket launches, space elevators could drastically reduce the cost of getting into space. Even better, with fewer rockets, we would see a big reduction in greenhouse gas emissions from traditional space launches. So, while we're still years away from building a space elevator, the idea continues to inspire scientists and dreamers alike. Who knows? One day, you might find yourself stepping into a space elevator and embarking on the journey of a lifetime. Thanks for joining us on this exploration of space elevators. If you enjoyed this video, don't forget to hit like, subscribe, and turn on notifications to stay in the loop. But we're not done exploring. Join me in the next video and delve into the world of human consciousness. We'll investigate one of humanity's most fascinating questions, the nature of our personal awareness. Until the next time.